today I want to discuss with you about the evolution of front-end architecture. Mainly this talk will give you an overview of what are the current state of front-end architectures. And then we will deep dive inside two, let's say, possible new way to structure your front-end application. One with communicating sequential processes, and one with reactive programming. So my name is Luca. I'm from Italy, but I live in London. I'm solution architect in a company called Massive Interactive, and I'm community manager for the London JavaScript user group. Let's start with some history about the architecture. It's very important to understand the path that we follow till now. So this is, let's say, a slide that I really like, because I'm trying to compare and talk about each single different architecture that could be applied to a front-end application. So let's start in the 80s, when we have model view control. I think that everyone here worked at least once with model view control. So model view control, as you know, is composed by three different areas. There is the model, where we are storing the data. We have the view, where we are rendering the data, and we have the controller that is basically the glue between these two elements. It could have different implementation, depends from the language, depends from the architect, also the tech lead that is implementing that. It could be that the model and the view doesn't have any clue about each other, or it could be that and the controller handling all the communication, or it could be the other way around, where the controller is just dispatching some events and the view has a direct connection to the model and retrieve directly data from there. So it's really up to you to define the architecture as you prefer. And as you know, it's very well known, and everybody is using at least once this architecture. Then in the 90s, there came out a new concept called MVP. For me, is a very cool architecture still now, because it's solving a lot of problems, in particular if you're working with cross-platform applications that are running in different devices, different targets with different views. The cool part of MVP is that the model and the view doesn't have a clue about each other at all. The view usually is a passive view. That means basically is a dumb view. It doesn't have any logic about what's going on inside the application, and there is someone, in this case the presentation model, that is a supervisor and controller, and basically is handling the view in fetching the data from the model and putting inside the view, and handling the possible interaction. And he has obviously a knowledge about the view. He has a strong knowledge about the application and how the view is behave. The cool part of this is the MVP architecture has a one-to-one relation between the presentation model and the view. And that means basically that when we want to swap a view maintaining the same behaviors, we can do that. And currently on front end, also in the JavaScript world, it's doable through transpiling. So potentially, if you want to create a cross-platform application that has different views for different devices, you can maintain the behavior of your application and swapping the view at compile time through conditional compilation. And it's very cool, because there are several technologies that allow you to do that, and at the same time, it's a powerful concept, because if you want to optimize your content, in particular for, I don't know, embedded system or set-top boxes, smart TV, or mobile devices, you can do that at compile time. And you don't need to have like large CSS that are handling everything for you, or large view that are reacting and behave across the different resolution. After that, in 2005, Microsoft came out with another concept that is MVVM. I think also this one is quite familiar for you. In this case, we have, again, view and model, but the middleware here is the view model. And the view model has a different concept from a presentation model, because in this case, again, the model and the view doesn't have any clue about each other, but the view has more responsibilities, has more knowledge about the application, is not a dumb anymore like MVP. And the view model basically is bridging and feeding the view through a binding system that is in place between the view model and the view. Again, also here, like a presentation model, the view model has the knowledge and the data that the view needs in order to be populated, but the view model could handle not only one view per time, but could handle more than one view. So then in 2009, the same creator of MVC came out with another concept that is DCI, is data context interaction. And in this case, is handling the problem of architecture software in a completely different way. So in fact, the DCI is one of the lean architectures, and is trying basically to change the way how let's say the engineers are architecting the code in a way that is mapping the domain of the business with the architecture, and not having, because if you think when you try to create MVC architecture, you are not really mapping your architecture to the real world. And often happen that when you communicate in a meeting with your customer or the product owners, the domain and the way how you call things are completely different from how the business are calling the same thing. Mainly because often the developers are creating names that are familiar for them, because maybe they are not familiar with the right domain. And this is a common thing. So with DCI, we are trying to solve this problem. We have a nice distinction between the data and the actors that has to interact with the data. In this case, is the context that is basically is the glue between the data and the actors, and they are trying to map in each single context what the data and the actors are interacting with each other. And it's an interesting concept. If you've never seen it before, I would suggest to give it a read and a try, because it's an interesting and powerful concept, in particular if you want to create a nice solution. Then in 2013, Facebook released Flux. Flux is, as you know, a library that allows you to pair with React and create this nice application that has one main concept that is unidirectional flow. So Flux is, if you read inside the documentation of Facebook, you can see that it's not just a library, the name of the library, but it's the name of the pattern. The pattern basically means instead of having, like in previous years, a controller that is handling bidirectional all the communication across the view and the model and so on. In this case, we have a unidirectional flow. And that brings a lot of benefit, in particular for large applications, because if I have new developers that are joining my team and they don't need to understand if the architecture is respected or not, it's super easy to implement them inside the team and start to speed up immediately. With Flux, the flow is always the same. So the view dispatch an action. The action is grabbed by the event dispatcher. The event dispatcher basically notify the store that there is something changed. The store is manipulating the data in order to change the state of the view and to change the state of the view. You can't change or break this flow. It's always in the same way. So if I have a problem between, I don't know, when the user is clicking on or interacting with an element and the action that passed through the event dispatcher, you can immediately spot it because it's always in the same way. So you know exactly where the problem could be. And then in 2015, and this is exactly what we are talking today, there was a couple of people that tried to exploring how to map and use all this experience that we have in the past 30 years in a new architecture called MVI, that is called Model View Intent. And in this case, we will see later on, it's interesting because MVI is an architecture that is trying to solve the problem to work with the reactive programming inside a front-end application. So what are the main challenges when we work with event-driven architectures? As you know, everything is nice and decoupled, and is the cool part of the event-driven architecture, because they grant us a lot of flexibility and give us the possibility to decouple properly the elements, add elements, remove elements without triggering errors if properly handled. But obviously, when we have a large application, it's starting to be challenging to follow the flow of where the events are bubbling and so on. So usually we try to find we try to work with events, but Also, we have other possibilities in this case. So we can use signals, for instance, that are real objects, are not relying anymore on strings. It's very cool because it has some functionality like, for instance, I can add once and just dispatch and listen just once to a particular signal. Instead, with events, I have to create logic inside my listener in order to handle this kind of situation. I can have a pub subsystem where basically I subscribe to an object, and any object would subscribe, unsubscribe, and be notified when something happens inside the application. I can have the Flux button with action and dispatcher. I can have comments. So I have several options to handle these things. Okay, I would like to add a further option to you, that is communicating sequential processes. I think from a backend perspective, you already heard about CSP. And basically, CSP is based on the concept on having a channel where two different objects are rely on, and one is writing the data inside the channel, and another one is retrieving the data from the channel. The cool part of CSP is not new. It's something that was created in 1978. CSP means communicated sequential processes, but it's not handled only for sequential processes, also for parallel processes. And it's interesting. It's misleading, the name, but it's interesting because it allows you a lot of flexibility to handle all the cases that you have inside your application. Currently in JavaScript, there is several libraries that basically you can use in order to have CSP inside your application. My favorite one is CSP.js, that is basically a porting from Clojure and Go routine, and is using the concept of Go routine inside the library. It's interesting because it's obviously flavoring the composition over inheritance, and also it's super easy to test because we are trying in this case to decouple completely and two different objects through a channel. Obviously, it tries to encapsulate everything in a nice and clean way, and it allows you to reuse a lot of code. In particular, when you want to reuse particular channels across the application or in different applications, you can grab these channels and move in another application quite easily because they are very atomic and easy to handle. So how you can use a channel inside your application? Currently, I'm trying to research a little bit which is the best way to handle these things. And I think the channel basically will be basically injected inside two different objects, in this case view and controller presentation model. It depends from what is your architecture. And basically the communication between these two elements, it will be between channel. The channel could, let's say, when the view is retrieving data from a channel, it could also write data inside the channel. So there is a bidirectional communication between these two elements through the channel. And this is something that I really, really like about this. Let me show you a quick example of this. So I created basically a small application that is a bingo system. I worked in the gambling game, so that's why I'm showing this. So it's really, really simple. So basically, as you can see here, we have two arrays that are the tickets that the user bought, and then we have an engine that is the system that is calling different numbers between basically 1 and 99. Every time that I spotted a number inside a ticket, I'm just saying, okay, you got a number in which ticket. So it's kind of simple, nothing major. Okay, this is a ticket, and it's going ahead till I finish to call all the numbers for that game. So if we want to take a look to the code here, so basically what I'm doing is creating a channel here, and I create a channel for the ball call, one for the ticket one for the ticket two, and whatever. And then this is the cool part. With the channel, I can use one channel between two objects, or I can use several channels and merge them together or split them, or whatever it is. I will show you later on what are the possibilities. So in this case, basically, I'm saying I want that these two channels are basically listened for the broadcaster that is this one, and is not broadcasting only to one channel, but is broadcasting to everyone. So basically, all of them are listening from the channel ball call. And when I create the bingo system, I'm basically injecting my, my different channels, but I already wired them together. And I have inside the ball call system, I have my, my main channel that became a multicast. So in this case, what I'm doing is very imperative programming. So as you can see, I'm describing everything that I'm doing. So when I start the system, I have a total call of 40 calls. Every 3 seconds, I call this method that is send data, and basically I'm sending inside the channel, I'm writing inside the channel the value, and I'm incrementing a counter that when I arrive to 40, I stop the game, I close the channel, I clear the interval. It's interesting how the ticket is working on it. So as I mentioned before, in CSP.js implement the concept of go-routine and is using exactly the generators that are present inside ECMA 6. So inside here, basically, is a special function. As you can see, there is the star, is the generator. And basically, when you are inside the generator, you can stop the execution and take it later on through yield. So basically, through this yield command, I can stop the execution of my application and resume when I need, when I receive a new data. So in this case, every time that I receive inside the channel something, I can easily check if the value is inside my ticket or not. So as you can see, the view in this case and the controller in the other case doesn't have a clue between each other. They don't know each other at all. We have an object that is used to communicate between two different things. And that's the cool part of this solution. Because, let me close this, and let's come back here. Because with this solution, as I showed you before, we can have really a pure decouple between the view and the controller, and potentially we can apply also to other parts of the application. And this is very useful, in particular if you think, okay, I want to create an application that allows me to swap between views or swap between behaviors without affecting completely the application. So also if you think about on a testing side, this is very, very helpful. So let's move on and try to understand what CSP are giving us. So the cool part of CSP is that it's very granular and allow you to do a lot of things inside the channel. So for instance, I can set a buffer inside the channel and say, okay, in this channel, I will pass always one value. In that case, you can create some rules inside the channel. So obviously, a channel allows you to put a value or retrieve a value from it. I can close a channel, or I can close a channel after a few seconds or milliseconds. I can immediately take a data structure, in this case an array, and put inside the channel automatically. I retrieve value by value inside the component, the object that is taking this value. So I don't need to write a logic that every now and then is passing a particular value inside an array, but just put the array and automatically is handling this thing for us. Now this is starting to be interesting. So I can split the channel, so I can create two channels because maybe I created at runtime another object and I need to listen to the same channel. I can split it, or I can merge. So I remove an object, or I need that two objects are listening to the same channel for a certain amount of time. So I merge the channel, and both are able to handle this communication. I can pipe the channel. I can have a pub subsystem, because CSP, in particular CSP.js, has a peculiarity that inside the application you don't work only with CSP, but you can also have out of the box signals, pub subsystem, so all the way how you're usually communicate inside your application. But the cool part is that you can apply this pattern and this particular way to communicate between objects only when you need and in the way that you need it. And that's the most important thing, because it gives you the flexibility that sometimes we start with, I don't know, an even bus, an even emitter inside the application, and we stuck completely with that for the rest of the application. But sometimes you need the flexibility to say, okay, for this particular communication, I really need to change this way. And sometimes this one, for sometimes laziness, sometimes you don't want to have more external libraries inside your application, you try to avoid that. In this case, you have everything out of the box, so you can choose and pick the best way to communicate between objects. You can broadcast values simultaneously, and inside the channel, you can also map, filter, or remove data, and that's the interesting part. You can avoid duplicated data out of the box. So you basically say to the channel, every time that you see a duplicated data, please avoid it, and don't pass to the other component. You can decorate data, so augment the type of data. And how do you do that? Through transducers. Transducers means is basically a composed word, transform and reducer. We transform, we try to transform some values. We reducer, we try to sum or reduce these values. The cool part of transducer, let's skip that and let's go directly here, is that I can apply that inside the channel. So that let's assume one thing. So let's assume that I have a stock application and I would like to show the data directly to my user. Depends from the country where it's based with the currency of that country. So in that case, for instance, if I want to do something like that in a normal application, I need somewhere to, I don't know, store native or on the backend, but let's assume that we are on the front end in this case. So you have the native data that are, let's say, the normal currency for stock application, usually dollars. So we use that, but I want to customize this view per each user. So where I can apply this transformation, I can apply on the model, I could apply on the view, but yeah, usually the view shouldn't have all this knowledge. I could apply on the presentation model or the controller, but why I can't apply inside the transducer and change it at runtime? That's the interesting part. So basically, I could have like a channel with a transducer that is only for, I don't know, euro, and another one for pounds. And accordingly to how I want to switch the application at runtime, I apply the right channel for the right user in order to translate the data at runtime in the right currency. And in this case, I can create something very nice, and at the same time, the application, the moment that someone will say, oh, you know what, we don't provide this service anymore, we just provide the data in dollars, I don't have to affect anything. I just have to put the right channel inside the communication between the presentation model and the view, and that's it. I don't have to change a line of code in what I'm doing. This leads to something, a new paradigm, or at least a paradigm that for front-end guys is kind of new and is a buzzword right now. This is functional programming. Functional reactive programming. Basically, as you know, there are several type of paradigms, and it's really, at the beginning, you start with usually imperative, then currently there is this movement of functional, and then now there is a niche about functional reactive programming. Reactive programming basically is taking the best of functional programming and is trying to solve the problem with asynchronous situation, where basically we are trying to solve in a nice and neat way some problem that we have with data that are continuously streamed from the backend or from front end or whatever it is. So from source. Why is so important currently reactive programming? Currently on the front-end side, and I know for sure that also on the back-end there are a lot of interesting things. There are some ideas. There is a draft that is present in ECMA 7, and basically, I don't remember the name, but someone in Netflix basically suggested to implement by default observables inside ECMA 7, and it's very nice, because the moment that this will happen, it will change completely the way how we are architecting our solution. Currently, Angular 2 is implementing observables by default. So they have RxJS, that is one of the main library for reactive programming, baked inside the framework. So the moment that you are working with Angular 2, you are working with observables in order to communicate, and you have the power and flexibility of the observables inside. There is this company called Fuse Tool that is based in Norway, and they use reactive programming by default, and they create basically a sort of unity for mobile application that you can write with JavaScript, you can write with C#, but they create this ecosystem. It's a nice company. If you've never seen it, I would suggest to take a look on them. Basically, they are baked in by default observables. So the moment that you are starting to work with views, you're working in reactive programming. And then on the other side, we have reactive extension, that is that one. Reactive X, sorry, that is that one on top right. And basically, that one is a library made by Microsoft, and you can have in several languages: Java, Swift, C#, JavaScript, whatever. In JavaScript, there is another quite famous that is Cycle.js, that is the second on the right. Cycle.js is the first proper implementation of reactive programming with an architecture, and that's why I mentioned that. And then there are several others like Bacon.js or Highlander.js and so on. So currently there is I can't say the need, but there are a lot of people that are explore this thing. And to be honest with you, it's really, really interesting because it's changing slightly the way how you're working, solving problems that usually it takes a lot of line of code to solve them. Reactive programming is based mainly on two patterns. The observer pattern, where basically we have a concrete subject that can basically, you can subscribe and add to observer or remove from the observer, and you can update the observer every time that something happens inside the application. And every time that something happens inside the application, you have an interface, depends which language are you using, that is implements inside an object, and every time that something happens, I notify that something happened, and through the update method, I can handle the different scenario inside my own object. And that's interesting because obviously it decouples quite well the way how you are working with objects. On the other side, we have iterator pattern that is basically traverse a container through basically going next and next and next, so moving forward and checking if there is a new element that I can use in order to traverse this thing. With these two patterns in mind, you can quite easily understand how reactive programming works. So one of the main challenges of reactive programming is, in my opinion, the vocabulary, because let's say they are talking about things that maybe we are using, but we don't know really at the beginning when they mention inside the documentation or the books what they are. So we are talking about streams, we are talking about cold and hot observables, we are talking about marbles diagram, back pressure, operator, stuff like that. So don't be scared about this name. I think that it's just a matter to spend some time to map this name with what they really do, but for the rest is kind of easy to understand. So let's try to create some vocabulary. So streams. So a stream, so first of all, on the bottom, you can see that one is a marble diagram. So basically, we have how you express when you want to talk with someone a stream. So you are saying in that case that we have, basically stream is a representation of your time, and you have from here, let me go there. So we have the time that is expressed in this line. We have the first value that is dispatched at this point, second value, third value, fourth value, and here you have complete the stream. So the stream is finished, is ended. If you see an X somewhere, it means that there is an error. It's kind of easy to understand marble diagrams, but you know, there are a lot of interesting resources online also to create them at runtime, and Firefox has an extension to see dynamically marble diagrams inside your browser when you are working with reactive programming. Apart from that, so a stream is basically, in a certain amount of time, I want to dispatch inside this stream some values. After a while, I can potentially handle errors, and I can send a complete signal that basically stop the transmission of this data to other someone that is listening for this stream. And then usually a stream is basically could be of two types. We can have cold observables, and we can have hot observables. Cold observables basically think that we have, okay, we said before we have observer pattern that behind the scenes. So let's think about that. So we have an observable that basically is composed by a stream. It could be cold, and in this case, when it's called observables, that means if someone is subscribed to that observable, when the first observer subscribes to the observables start to share the data that are inside the stream with the observer. But if, for instance, after a while, dynamically or through a timer or whatever, we had a new observer that is watching or is listening to that, subscribing to that observables, is not retrieving the previous data, but is retrieving the data from the moment that he subscribed and then. With hot observables, it's completely different. So with hot observables, if you need, for instance, that you have streams and again, you are in a situation where you need to retrieve all the data or a part of this data, because you can set a buffer inside the hot observable, inside your observer that subscribes to an hot observables, you can do that. So immediately, the first thing that a hot observables is doing, the moment that someone is subscribing to it, is passing all the whole data, and then is moving ahead with let's say, the data that are the nature of the application. So it's very interesting because obviously you can swap between a hot and a cold observables with a line of code. And that means for you, you can have a completely different behavior inside your application quite easily and quickly. And that's the most interesting and flexible thing. Before show another example, I would like to talk about operators. With reactive programming, you have a lot of operators. So you can handle a lot of situations that sometimes in imperative programming is becoming, I can't say tricky, but it's becoming, let's say, more verbose. And you have to keep state inside the class. You have to write quite a few lines of code. In this case, is the library that is handling everything for you behind the scene. And for you, it would be super easy to change the behavior of your application. So if I remember well, perfect. I'm in the other example. So let's take this there. I want this. So I recreate exactly the same example of before. Let me show you here, but in reactive programming. So let me close this. Cool. So let's go here. Again, I have my two array here with all my elements. I hope it's the right one, yeah, I guess so. And I retrieving all the data. So basically, what I'm doing, again, is a call to a particular, basically the engine is calling a number. We are checking inside each ticket if the number is matching, and that's it. Okay, cool. So if we move to the code side, let's try to do, let's discuss a little bit of this. So what we have here is our bingo game that is composed by, obviously, the starting point is app.js, and then we have a ticket, and we have the ball code system. The ball code system, this is a code observable, is based in this way. So in order to express all the things that I was doing, so creating an interval that every now and then write inside the channel a value and check if is the last value and whatever it is, I express exactly the same thing in these 3 lines of code. So what I'm doing here is basically saying I create an observable that every now and then is, and in this case the interval is this constant, so every 3 seconds, every now and then is dispatching a value in time in this case, so starting from 0 and incrementally going ahead. And every time that I dispatch a new event, I map this value, I retrieve this value, and I use to pass the first value inside my array, and basically I write inside my stream. And then when I arrive to have 40 calls, so 40 times this thing, I stop the observable, so I close the observable. In order to handle, as I said before, the first time that an observable is, an observer is subscribing to an observable, immediately the observable starts to dispatch this information inside the stream. So in order to handle that, you can also postpone the start of the stream, just using stream.publish. So in that case, you can connect and disconnect the stream when you want. So you have a control over the stream and saying, okay, you can connect to the stream and you can start to retrieve data, and then at a certain point, maybe for user interaction or whatever, you can stop that and resume when you need. So it's very powerful, this thing. And what I have here, basically, in the ticket, I take the observable, and I just subscribe to it. Another nice thing of reactive programming is that you are forced to handle all the different cases. So you handle when the data is arriving, when there is an error, and when the communication complete. Usually, if you think about the normal, let's say, implementation, in particular on front end, you usually you can handle, if you're working with TD strictly, all the errors and all the other things, but sometimes you miss something. In this case, you can't, because otherwise it's not working the code. So in this case, what we have is that on data, I'm checking the data, if the value is correct or not, and so on. If there is an error, I dispatch that it's an error, or whatever it is. The interesting part, again, here is I have created a bulk system. I have a ticket where I inject the observables retrieved by the engine. I create a true ID, fair enough. But what happens if, instead of doing this and create the second ticket at the same time of the first ticket, I create it after 5 seconds that we start the game? So let's try to do that. So now, as you can see, I have the first ticket, that is this one. Now I added the second ticket. Okay, let's stay here. So here we called 68, 85, 9, 98, and so on. And then the second ticket that subscribed at that moment when it was created, basically, to the observables, we start to listen from the moment that it subscribed. So it doesn't know anything about the other numbers that were called before. And that's the problem, because in a bingo system, you need to check from the beginning of the game to the end of the game what's happening inside the application and what are the numbers that were called. So in this case, let's change this thing again. Let me do this. And move to an auto observable. So the auto observable, has the peculiarity that I described before. So as you can see, now I have a new engine that is called Post Call System Replay. And the replay one, in order to become an auto observable, we just need to add this. As you can see, it's exactly the same code. I didn't change anything. Exactly the same expression and the thing that I'm trying to do. The only thing that I added is share replay. And share replay basically is translating your code observable in a hot observable. So now what we expect is that if someone else is subscribed to this observable after a while, he should be able to retrieve all the information that were streamed before he subscribed. And the other interesting thing is the share replay, and we can set a buffer inside this method, and we can say, oh, you know what, you don't really be interested in all the data that we received before. You just be interested on the last 3 or the last 4, whatever it is. In this case, I need to retrieve everything. So now this one here, okay, so this one is fine. So now, if I compile again, oops. Okay, as you can see, I have the first ticket. It's calling second ticket. The first thing that is happened here, I retrieve the other things. So I have 97, 75, 99. The first ticket was called before the second ticket was created. And then automatically, I retrieve all this information immediately in my ticket in order to check if it's working or not. And I change one line of code. So let's move back because I have 5 minutes. Nice. Okay, so we talk about MVI. MVI is an architecture that is model view intent that is described in this diagram. So basically what we have a view and model, I think, is self-explaining. We have an intent that is something that is completely different. As you can, if you follow the arrows, you can see that basically we have the view that is, all these elements are basically communicating through observables. So, and this is the only touching point between this object. So the moment that I want to swap a view with something else, I can do that easily because the only touching point between these two elements is an observable. So the only thing is writing stuff inside the stream and retrieving this information from the stream, and that's it. I don't have to do anything else. The cool part is, as you can see, is a unidirectional flow because basically the view exposes the observable to the intent expose is observable to the model, and the model is exposing is observable to the view. And what it means for us, it means that first of all, in order to have this architect in this way our application, we need to create small components, so small chunk of code, and that's very important because it's easier to spot a bug, it's easier to write. You can, let's say, share the creation of an application to different developers. So there are a lot of good ways to handle this. The second thing interesting is that it's a unidirectional flow. So the things that I discussed before regarding Flux are applied also here. So if I have to understand where the problem is, I immediately spot it. I don't have to search if my developer followed the architecture or not, because that's the only way to communicate. You can't break it at all. Obviously, yes, you can, but in general, in theory, you shouldn't. And then another interesting thing is the view is not what we call view currently, that is the thing that are rendered, but basically the view is let's say the concept of virtual DOM. Currently there is React that is using very well this concept. So basically is analyzing through a different algorithm what's happening behind the scene and then updating only the part of the HTML that you need. So there isn't only React. There are also other libraries that allow you to do that. For instance, Cycle.js is not using React by default, but is using another one that is very powerful and well described. And in this case, it fits perfectly at a library like React for the view, or like virtual DOM should be, where basically we have we can use this one where the view is just a representation of what I have to render, and someone else is delegated to render properly the HTML how I want it. The renderer usually is a component that is, I would say, quite invisible for the developer, because it's just like in React or in Virtual DOM library saying, okay, I need to create a div where inside there is a button or there is a form or whatever it is. So this thing, you're just passing what you would like to render, and automatically behind the scene is creating your stuff. So the renderer part is basically something that is completely transparent for you. MVI rules, how it works. So a module shouldn't control any other module. So again, the only way to communicate with between modules is only through observable. The intent is a component that has just one responsibility, and basically should retrieve what's happening inside the view through the interaction of the user, retrieve that, understand what the application should do. So I don't know, calling I don't know, a proxy or an endpoint to retrieve data or whatever it is, saving the data model, and then act in the way that the model will be updated, and then the observable inside the model is, when the model is ready, is basically writing inside the stream the data for the view. And it's always working that way. So the pro in this case is better separation of concern, definitely. There is a monodirectional flow, like we discussed regarding Flux. Everything is handled by dependency injection, so you can easily testing your stuff. The application is become easier to test, in particular for the views. That is one of the problem quite often that for lazy developers, they don't have time to test the view, but it's not completely true. There is a way and there is a time, particularly if you work with React and RxJS. There are a nice testing utilities that you can have built in inside the library. All the states live inside the model, and it's very, very interesting in this case because you can understand what's going on inside your application and handling the different state inside of your application directly in one place. And these are, in my opinion, the pros to working with MVI. Currently, still, I think there are some area that should be, let's say, should be discovered properly because they basically announced this new architecture only last year, and I think before we arrive to the maturity, it will take other few years, but definitely we are in the good direction. So at the end of the topic, I know that I literally ran through the discussion, and there is a lot of things to do and discuss about reactive programming. But again, one question that I raised, and I think is, let's say, quite normal, in particular in the JavaScript community, considering the amount of libraries that are raising every day, can I use CSP and reactive programming in any project immediately? So my answer is no. This is not an answer from a developer perspective, it's an answer from an architectural perspective. So currently, you have to understand exactly what your application should do. So if you are handling the problem like the bingo system that I showed you, that you have to render data every now and then and do some checks, I can tell you that with reactive programming, you have like, I can't say 50% of the code less, but probably 40. Because the way how it's solving the problem is way better than imperative programming. But obviously, at the same time, I see a trend in the JavaScript community where now React is the cool thing, and everyone is using React for everything. So also, if you have to render, for instance, I don't know, contact form that never change, we use React because React is cool. It's not working that way, unfortunately. You have to pay attention, also because React, honestly, is not even the fastest library to render and manipulate the DOM. So you have to understand what you need to do and which is your case for your application. So definitely taking a look at these paradigms, it could help you to implement in some project, but probably it's not the silver bullet for everything. So you have to understand literally what you have to create, because otherwise you end up, like I'm seeing right now, reactive programming that is becoming the buzzword. A lot of people that are changing their website that are basically single page app, static, that are rendering static data, everything with reactive programming, just because, yeah, it's cool. It's not working this way, unfortunately. When you work in particular project that needs to handle asynchronous situation, that's where reactive programming is shining. Otherwise, let's try to use the right tool for the right project. And that's it. Any question? Cool. Or you are amazed, or you are bored. Okay. Okay, thank you very much, guys, and thanks.